I'm showing you these arc shots before we get started because I want you to know that this is what's waiting for you if you hang with me till the end of the video. I do a little bit more talking than normal today before we get into the welding, and so I figured I'd show you up front what you're in for if you can hang with me. And if you can't, just fast forward and watch what you want to. Alright? Alright, this is Jody with another weekly video. Let's get right to it. Today we're going to be talking about what you can do with a torch switch. A lot of machines come with just a switch and a foot pedal's extra. So what's this thing for? What can I do with this thing? There's no amperage control. All it does is turn the arc on and off. Is that any good? Well, sometimes it's not bad. One good thing about it is if you do this for a while, you get a really good idea on what amperage it takes to do what, because you've got to set the machine amperage on the machine pretty darn close to what you need, or you're getting kind of a bind. But there are a few little tricks, a few little things that we can do with this torch switch that are kind of cool. And one thing is we can do manual pulse welding. Last week's video I did manual pulse with a foot pedal. You can do the same thing with a torch switch, and all we need to do is go to the 2T setting on the machine, and we're going to set the upslope at 0 and the downslope at about somewhere between 2 and 3. So what that does is I get all my amps at once, whatever I have set on the machine. Today I'm going to be welding 065 wall aluminum tubing, some little joints, and I'm going to stick them up overhead and do them to make things more fun, more interesting. I mean, you can't just weld on the bench all the time, right? So anyway, to make things a little bit more fun, and when you're out of position like that, that's when a torch switch is kind of handy. Dragging a foot pedal around or trying to walk around all the way around the tube as far as you can with your foot still on the foot pedal can be a little bit of a challenge. So the torch switch is a good thing to have. They're very inexpensive, and you can leave it on the torch even while you're using your foot pedal. You can unplug your torch switch and plug your remote foot pedal in, and when you want to use a torch switch, you can. So it's got uses. I'd rather have a foot pedal most of the time, but hey, we're just looking at stuff to talk about in a video, and it's useful sometimes. Another area that I use it is for speed tacking, what I call speed tacking, where I'll set the electrode, like especially works great on steel and stainless steel, not so much on aluminum, but steels and stainless steel. You can set that electrode way up in the cup, like barely sticking out, or sticking out just far enough to where you can rock it, touch the tip of the electrode right where you want to put that tack, and then rock it back just a little bit to get maybe a 1/16 gap. You hit the switch and get off of it with almost twice as many amps as what you would weld with. So if I'm doing 1/16 or 1.6 millimeter stainless steel, I'm only going to need maybe 50 amps to weld it with, but I'll set the machine at about 100, and I'll just pop it just as quick as I can get on and off the switch, and it puts like a laser focused tack. Doesn't hardly heat up the area, usually won't even melt through or discolor the back side. Today I've got a couple of jobs that where this would come in really handy. One of them is doing that same, we're going to do that those aluminum little coped joints overhead. We're walking around that thing, pulsing with the torch switch, not on and off like bump welding, but with a little bit of downslope on the back end. Some steel parts, some small steel parts that are a 1/4 inch thick, high strength steel, and little outside corner joints. Don't really need much amperage control on there. I can set the machine and just use the 2T setting with upslope and downslope, and that'll work out fine. So let's weld these things. Alright, in case I rambled too much for you and lost you, here's what we're going to go over real quickly. The quick burst tacking that I called speed tacking. We're going to TIG weld the thicker steel parts using upslope, downslope, and we're going to manual pulse on aluminum tubing using the torch switch. Alright, first the speed tacking. The fit up's got to be good. You can't have a gap or it won't join together. Or you can't have hardly any of a gap, like, you know, tissue paper type gap. So the way to do that is set the machine roughly twice, again, what you would weld it. I'm going to weld this at about 60. So I'd probably set the amperage at 100 to 120, rock the torch in, hit the switch, boom. All right, for this steel part, I don't really have to have upslope, but I'm going to set the upslope about 4 seconds to give me just a little while to get the filler wire in there before I start melting the corner. Downslope also set to about 4 seconds, just enough to taper off and avoid leaving a crater eye. I'm using 1/16 wire. That's a little small for a job like this, so there's a lot of feeding going on, a lot of dipping.
I could easily use 3/32, just couldn't find one right away and decided to grab a small one, this ER70S6 filler wire, 1.6 millimeter, 1/16. And you can see it taper off here, taking about 3 or 4 seconds from the time I let loose of the switch. You can also just as easily leave the wire in on a joint like this. In fact, sometimes it helps the puddle run a little cleaner, kind of satisfies the puddle, but you can see some oxidation pulling in there from the backside. There's a little gap in the root. It's just kind of like a root pass on a pipe. You're always going to have the oxidation and silicon islands floating around unless you're purging the inside with argon, and it's just not necessary on something like this to purge the backside. So that is a small weld, a little bit too small for, 1/4 inch high strength steel like this. So I'm going to beef it up a little bit with a second pass. There I found the bigger rod. And again, I'm just using the lay wire technique here, leaving the rod in the puddle. Again, about 125 amps. A little bit of pressure on the rod to feed. If it wants a little rod, it'll feed it in there. Not trying to force feed it, but just keep a little pressure in there so it won't ball up. That's better for the thickness of this part. And it kind of reminds me of this socket weld video I shot some time ago. Same kind of deal. You put a root pass in there to get penetration into the root of the joint, and then come back with a second pass like this. I'm walking the cup here with a second pass with just leaving the wire in there. This is only schedule 40 pipe, so it only takes 2 passes, but there are heavier duty socket weld fittings that take, many passes to fill them all the way to the corner with thicker wall pipe. And again, that was done at 125 amps, so I was using a torch switch on there as well. And this is the part that we speed tacked earlier and set it to about 60 amps with the little trigger switch. No filler wire, but no gap, so I'm just using a little circle technique here, rolling the corner of the tubing over in for filler metal. This particular joint was just like a handle on a cart, and those brackets got welded and it really couldn't go anywhere, so there's really no point in adding filler to this. Again, you learn the amperage when you're using a torch switch. If you're using a foot pedal, you don't really have to. You just use what it takes, but you have to set the machine pretty close when you're using a switch. All right, that's a little angry mosquito third hand I made a couple weeks ago, playing around. And for tacking like this is pretty thin wall. This is about a 1/16 thick, 0.65, 1.6 millimeter. I set the upslope all the way up to about 10 seconds because I kind of wanted to, I didn't want to overdo it and, blow a hole. I wasn't really sure what amperage it would take at first to get a small tack on there, so I just set the upslope to a long time so that when it got there I'd add rod and then get off of it. This is the way the pulse works here. You see I'm already getting the torch angle a little bit, too much, but it's hard to keep it just right on 1-inch tubing when you're walking around it. And all this repositioning going on, again, it's easier to do with the torch switch than it is to try to keep your foot on a pedal if you're walking around something like this. I settled on about 90 amps. First I did one with 110 amps. It was a little hot, especially when there was any gap at all. 90 amps seemed to work out pretty well. About 2.5 seconds on the downslope, and that gave me just enough time to reposition myself to get the rod back in there and be ready to add rod. Let's get another look at that. Now the aluminum tubing is pretty toasty right now. You can see I'm wearing a TIG finger. I'm propping right down there. My finger's cool. That is where it comes in handy. Lets you prop wherever you want to. Here's another shot of it. On the high side, get the rod in there, and then as it tapers off, move to the front of the puddle, and then hit the switch again. And try to do it at a fairly uniform rate. And if you have a pulse setting on your machine, you can always use that. The only downside of doing that is it's going to pulse when you have it set to pulse. And if you get hung up a little bit and you're not ready, then it can be a little bit of a problem. The manual actually works a little bit better sometimes. So one more time. This is where I finally settled in at 90 amps. A little bit more controllable. Gives me time to reposition myself. and the keyhole's not getting out of hand with me. If you do everything uniform, it comes out uniform, but you know, I'm going to go practice. All right, well, you saw me using the Tig finger product on the tubing there. If you've ever welded aluminum tubing like that, you know how hot it gets, and you know how beneficial it is to be able to prop right where you want to prop instead of way further back. So we'll see you next week.